Hello students, welcome to the lecture number 8. In this lecture we are going to discuss a very important topic, that is the spectrum. That in this lecture we will be going to discuss the line spectrum or different type of spectrum that is necessary for us to understand. What is the main necessity of knowing the spectrum? Because you know, the atom is a very minute particle, you cannot even see in your naked eyes. And when we are going to understand the inner structure of this atom, you need some help, need some information that is being indirectly produced. And spectrum is one of those information that you can have, that it can give you immense information. And it is also a fact. From the spectrum, we will be able to understand the quantized energy of the electron. That we will understand gradually in the next video or after the next video in the Bohr model, that we will understand that electron will only emit or absorb a fixed amount of energy. This is called the quantization of the energy. That we will understand, we will learn this in the afterwards. So in this video we are going to discuss a very important topic, that is spectrum. This is K.K. Mukherjee in the Science with Mukherjee Sir YouTube channel. In this lecture we are going to understand what is spectrum. Spectrum is basically a recording of the wavelength that is emitted by a radiations from the source. It is a recording in the photographic plate. So suppose you have been told that write the definition of the spectrum, then what we will do? You have to write something that will express what it really is. So definition of the spectrum is this is the definition of spectrum. It is a recording of wavelength, that is frequency, radiated by source in a photographic plate. Now, spectroscopy, the study of spectrum, the study of spectrum is spectroscopy. The instrument used So these two important terminology that we need to understand, that is study of spectrum is spectroscopy, and the instrument used to study the spectrum, is called the spectroscope. This is the two important term that we must know always. Okay. So study of spectrum is spectroscopy, and the instrument used to study the spectrum is called the spectroscope. So depending on the type of radiation that is emitted by the source, the spectrum is classified into the two types. One that we will discuss here now. Now we are going to discuss the classification of classification. There is two classification. Number one, the emission spectrum. Number two, that is your So we classified the spectrum in the two ways. One is emission spectrum and another is the absorption spectrum. What is emission spectrum? Emission spectrum is when the radiation emitted by the source has been analyzed by passing this radiation through a glass prism, and this is analyzed, and this will analyze and this is captured in a photographic film. We will get the emission spectrum. Emission spectrum means that emitted radiation has been analyzed after passing it through the glass prism, and it will give a different type of spectrum, that is called the emission spectrum. So we can write this definition. It is produced by passing radiation through glass prism. This is called the emission spectrum. Again, emission spectrum is classified two ways. What are the classification? Classification is one, that is continuous spectrum. So, emission spectrum is classified in two ways. One is continuous spectrum and other is your line spectrum. So now either you try to understand what is the continuous spectrum. Continuous spectrum is produced when we pass a white light through a glass prism. It is being splitted into the different colors, that is the 7 colors. This is called the behavior, and it having a continuous trend, continuity in the colors. This type of spectrum is called the continuous emission spectrum. So continuous emission spectra, that is one of the example is the rainbow that we can see on the earth after the up in the sky after the rainy season. Then you will see there is a behavior, that is the color bands there. So continuous spectrum we can So this is a white light, and white light is passed through a glass prism, and it has been collected in a photographic plate, and we will find there is a continuous band of colors, and these colors is, you can see, that can be summarized here, that is behavior. V means this is violet, I means indigo, blue, B means blue, G means green, Y means yellow, O means orange, and that is red. So this has a continuity in the colors, because the violet will merge into the indigo is merged into the blue, and it is goes on like this way, that is there is a continuity of the colors, and that is why it is called the continuous spectrum. Now question arises, why there is a splitting of the white light? White light is basically consists of all the wavelengths in the visible range. When it is passed through this glass prism, what is going to happen? The speed of this, all the wavelength changes, and the red light will be a higher speed and the violet light will be the least speed. That is why violet light, you can see, that is bent with the maximum range, and the white light, that is a red light, will bend least. So we will find a splitting, and this splitting is called the dispersion of the white color. So this is how we can say this is a continuous spectrum. It is the band of colors, that is, there is a continuity in the band of colors, and you will find that this is happening like this way. Now we will understand the line spectrum. Now we are going to discuss the line spectrum. Line spectrum is basically produced when some volatile substance is heated and the atom of the volatile substance, the electron, basically we could say the electron in the atom is excited to the higher state, but this state is not a stable state. It will revert back to its ground state. At that time, what is going to happen? It will emit the electromagnetic radiation, and this electromagnetic radiation, it will appear in the photographic plate, and we will found some characteristics bright line that you can see here. When initial, this is a platinum wire, we are make some initial, there is initial in this tip of this platinum wire, and when this is giving to the burner, this is basically burner, and this burner is hit this initial, and it will radiate, and this radiation will go through this glass prism, and ultimately it will going to happen. What is going to happen? There is in the photographic plane we will observe some bright yellow line which is having the wavelength 5898 angstrom and 5890 angstrom, and this is the characteristics of the sodium element. Everywhere you can do this test. You will take the spectrum of this sodium, you will get these two lines, that is 5898 and 5890, and this is a yellow line. So this type of bright lines you will see, and there will be the gaps between this bright yellow line, and this is why this type of spectrum is called the line spectrum. And line spectrum, you can see it is the unique of any element. We can write line spectrum unique of any element. The scientist Boumoussant used this technique to classify, to identify the element. He was the first one to identify this element. And in this way, lot of elements have been discovered, that is gallium, scandium, indium, all those elements that you can see discovered in this way. Even in the sun, we observe from the line spectra of the helium, it is been find out that there is a helium element in the sun. From now we are going to discuss the absorption spectra. What is absorption spectra? What is absorption spectra? Absorption spectra is when white light is passed through a substance, solution of a substance, or through a vapor of a substance. What is going to happen? And this transmitted light has been passed through a spectroscope, and it has produced the absorption spectra. What we find, the some portion of the visible spectrum, some wavelength of the visible spectrum has been vanished. There is a dark line as if it is absorbed by some substance. So This is how we can able to produce the absorption spectra. You can see this white light, there is a slit, it goes through a solution of NaCl, and this transmitted light has been passed through a glass prism and it will produce the absorption spectra. What we will find in the absorption spectra, there is, you can see there is a dark lines at the wavelength 5898 and 5890. There is a dark line in these two yellow region of this spectrum. Otherwise, this is continuous. So you can see absorption spectrum, you can observe there is a dark line in the continuous spectrum. Dark line that is being correspond, that is a indication that this substance, that's the initial solution, has absorbed some portion of the wavelength that corresponding to this dark line. That is why it is called the absorption spectra. So we can say absorption spectra is basically the negative, photographic negative of the emission spectra. We can write absorption spectra So absorption spectra is basically the negative of the emissions, photographic negative of the emission spectra. That portion will show the dark lines, and this wavelength has been absorbed by the solution. Here NaCl solution we have taken, and Na absorbed the two lines, two wavelengths in the yellow region. If it is a emission spectra, we can observe there is a two bright yellow light and other portion is dark. But here you can see there is a dark line in that portion, that is in the yellow portion, yellow line portion, and another remaining part of the spectrum is continuous spectrum. So how do we differentiate between your emission spectrum and absorption spectrum? That emission spectrum is basically there will be always a dark light, and it is the photographic negative of the emission spectrum. Emission spectra is created from the radiation of the source, emitted by the source, whereas the absorption spectra is created by the transmitted portion of the white light which is passed through a substance, and this substance will take up that wavelength which correspond to the dark line in the emission spectra, in the absorption spectrum. Otherwise it was a continuous spectrum, but due to this absorption of the wavelength, this portion will show the dark lines, and that is the absorption spectra and the emission spectra. Okay, so that is in this video we have discussed about the spectrum, different type of spectrum, and definition of the spectrum, and what about the continuous spectrum, and then we have discussed about the absorption spectrum and also the line spectrum, and we have understood that line spectrum is very important spectrum. It can give you lot of information about the atoms of the element, and it is the unique. It is also sometimes called the fingerprint spectrum, because fingerprint of the human being a unique thing. From this you can get an identity of a human being. Similarly, for an element, from this spectrum you will get the identity of the element. So I think you have understood it, and if you have any query, you can comment on the comment section box. And till then, next video will discuss the line spectra of the hydrogen, and that will be very much important. A lot of questions may come in that portion. So next video with the line spectra of the hydrogen will meet. Till then, all the best and be best.